Okay, as there is a lot of panic in my class concerning the simplifying expressions with radicals and indices, this video is gonna show you some tasks or exercises, and I'll try to solve a couple of things about this. Okay, so let's start with the first exercise. We have to simplify these radicals. So basically what we can do here, we can see that 45, 20 and 125 are not nice numbers to square root them. So we will try to simplify and make prime number factorization. So 45 is 5 times 9, which means it is 3 to the second power times 5, plus 20 is 4 times 5, which means it is 2 to the second power times 5, and the last number 125 is 5 times 25, which means it is 5 to the third power, and it would mean that as we can see, the first radical can be simplified like square root of 3 to the second power times square root of 5, and we can simplify this square root to number 3 because we have perfect square under the root. So basically we can simplify our expression being like 3 times square root of 5 plus, the same applies in this term, 2 times square root of 5, take away, and as we can see, this is like 5 to the second power times square, like times 5, and the square root of this, which is square root of 5 squared, times square root of 5, which can be simplified to 5 times square root of 5, and as we have the same square roots of the same base or radicand, we can simply do the addition. So 3 times square root of 5 plus 2 times square root of 5, take away 5 times square root of 5, would lead, and the result would be 0. Okay? So this was the first exercise. Let's have a look on the second exercise. So we will not need these anymore, and we go to the second exercise, which is this one. Here basically the same procedure will apply. The only difference between the first exercise and this one is we now talk about the third root of some radicand. But basically, as again we don't have prime numbers under the root sign, we still can do the prime number factorization of number 16, so we can simplify this like 2 times third root of 16 is 2 to the fourth power. Okay, because 2 times 2 is 4, times 2 is 8, times 2 is 16. Take away third root of 54. Okay, what is 54? It is 6 times 9, and I will help myself, so it is like 2 times 3, this is 3 squared, so under the third root we will have like 2 times 3 to the power of 3. We don't need this anymore. And now the solution is really like very easy, because the first term can be simplified like 2 times 2 third root of 2, yeah? And the second root can be simplified as we have the same power as the power of the root. We simply write this as take away 3 times oops, third root of 2. Yuppie, this is really like good news for us, because it means we can simplify this expression like 4 times third root of 2, take away 3 times third root of 2, and the result will be third root of 2. Okay, so this is our solution of this exercise. Okay, the next exercise, as we are not going to use this anymore, we will delete, and let's have a look on the third exercise, which is this one. Here basically we want to get rid of the square root of 2 from the denominator, so we have to rationalize the whole expression or fraction, which means the easiest way how to do it would be we do multiply this fraction by number 1, but basically we will represent number 1 with this expression, and the thing why we are doing it so is the formula we already know, that a minus b times a plus b is a squared minus b squared, which means if we have here any square roots, and it doesn't matter, we can have square roots in a and b, this operation, if we do square root with the same base, of course, we will get rid of the root or radical. So basically we do apply like 2 times square root of 2, we calculate numerators, plus 2, take away 2, because square root of 2 times square root of 2 equals 2, of course, and we will have like take away square root of 2, and in the denominator we will have like 2 plus 1, 2 minus 1, so our result will be, we will get rid of these two 2's and we can subtract these two radicals, and the result, as you can see, will be square root of 2. This is it. Okay, so this was the third exercise. Let's go to a little bit more complex exercise or task, which is this one. So let's have a look what we can do here. Basically, I'm not sure what to do as the first step, but I'll just use the formula, and this would mean that we can simply write this like square root of 4 plus square root of 7 times square root of 4 minus square root of 7, yes, plus 2 times super special square root of 4 plus square root of 7 times square root of 4, take away square root of 7, plus okay, I made a mistake, now I know. Okay, so this is wrong. Okay, why is it wrong? Because I didn't use the formula properly. Basically this is our a and this is our b, which means a squared is 4 plus square root of 7, okay, plus 2 times square root of 4 plus square root of 7 times square root of 4 minus square root of 7 plus b squared, which means 4 take away square root of 7. So I just use the formula a plus b squared equals a squared, okay, which is this one, plus 2 times AB plus B squared. So this is my B squared. Actually this one squared will help me to get rid of the first radical. Okay, so let's have a look what can we do like next. Okay, I can see that I will get rid of these two radicals, so my next step would be 8 plus 2 times square root of 4 plus square root of 7 times square root of 4 take away square root of 7, which basically means this is like 8 plus, and I'll try to simplify it this way. I want to know what is happening here because I don't know now. This is like a to the r times b to r, and it would mean that we have to do the multiplication, because then it is a times b to the power of r. So we can simplify it like 8 plus 2 times and now, as we can see, this is gonna be square root of 4 plus square root of 7 times 4 take away square root of 7. Yes, so I do the multiplication here, and this is really good news. Now I can see it, because this is like a plus b times a minus b, which will again lead to this super special formula, and it means a squared minus b squared. So my result, or next step here, would be 8 plus 2 times square root of 4 times 4, which is our a squared, is 16. Take away square root of 7 times square root of 7 is 7. So it would be 8 plus 2 times square root of 16. 16 take away 7 is 9, which is really good news. So the result will be 8 plus 2 times, but I'm sorry, here the square root is missing, so let's do it again. Square root of 9, which is 3, then it is 8 plus 6, which is 14. So very nice number. Okay, this one was really a little bit tricky, so you better watch this solution like 2 times. I was not sure about coming from this step to this step. That's why I used the super special formula. I have rewritten this multiplication by using not radicals, but using the indices. Okay, and then I found out that this really works. So I can, if I have the same power or same square root, in this case I can use the formula square root of a times square root of b equals square root of a times b. Okay, let me basically just write it, because the square root of a times square root of b is equal to square root of a times b, which is more or less the same thing, which applies for the indices. Okay, so the result will be 14. Okay, this one was a little bit tricky, but we found the solution. And as you can see, Mr. Teacher sometimes needs to think about the procedure how to solve it. Okay, next task, let's solve this one. And again, to be honest, I don't know what to do, like, but when I look at this, first thing I would do as I have the plus sign here and I have the square roots in the denominators, I would first rationalize both fractions. So it would mean that I will have like 2 plus square root of 2 over square root of 2 times square root of 2 over square root of 2 plus square root of 2 over 2 plus square root of 2 times 2 take away square root of 2 over 2 take away square root of 2, the whole expression being squared. Okay, so from the first multiplication I will get 2 times square root of 2 plus 2 over 2. Good news, because I can see here already that I will get rid of these 2's, plus here I will have 2 times square root of 2 take away 2, good news again, over, and this one will be 2 times 2 is 4 minus 2 because I used again the same formula. So as I said before, I can simplify this fraction. And why or how can I do this? I'll explain, but now I have realized that I'm missing square the second power with the whole expression. But basically, maybe it's not a good idea to do it right now, because as you can see here, the denominator will be number 2, so I can simplify again, and I will do it this way. I will find the common denominator, which is number 2, which would lead to 2 times square root of 2 plus 2 plus 2 times square root of 2 take away 2 squared equals. And why I did this decision? Because I can see that I will get rid of these, and the next step would be 2 times square root of 2 plus 2 times is 4 times square root of 2 divided by 2 squared equals, and now it's really easier, as I wanted to do it before. This is a more clever idea now. So then this would be 2 times square root of 2, the whole thing squared, which means 4 times 2, and this is 8. Very nice number. I'm happy with that because I know this is my result. Okay, very easy. And just realize that nothing special is happening here. We are just using the formula a minus b times a plus b equals a squared minus b squared. This is it, nothing special. And just using a couple of rules for calculating the indices and radicals. So let's go to this one. Okay, this one is, in my opinion, really very easy. What I would do as the first step, I would get rid of these two powers or exponents if you want to, and this means I am going to use a to the power of r and then to the power of s, which means a to the power of r times s. It would lead to 10 to the power of negative 3 times 1 over 3 will be negative 1 times 8 to the 3 halves, okay, because negative 3 times negative 1 over 2 is positive 3 over 2. This one I'll do the same thing, so it's gonna be 25 to the power of 1 over 2 times, and in this case I'm going to reduce 8th root of 4 being like 4 to the power of 1 over 8, okay, and then I'll use our formula here, so it would be 4 to the power of 2 over 8, and when I simplify it's gonna be 1 over 4, okay. Now, as you can see, all these bases are not prime numbers, and I'm not sure and I don't know what to do and how to simplify it. So I'm gonna do it this way. As far as we already know, this can be transformed or put into the denominator, so I will do it. But before I start, 8 is equal to the third power, which means 8 to the power of 3 over 2 can be transformed like 2 to the power of 3 and then to the power of 3 over 2, which when we simplify, it's gonna be 2 over 9 to the power 9 over 2. Okay, because we used again this the same formula. So this is gonna be 2 to the power 9 over 2. 10 is going to be down, which means 10 is 2 times 5 times 25, and we use the same procedure as we did here. This is like 5 to the second power, and so this is gonna be like 5. Okay, because this is 5 to the second power to the 1 over 2, and I do the multiplication, which will lead to number 1. And basically, if you realize one more thing, 25 to the power of 1 over 2, this can be written like second or square root of 25, which is square root of 5 squared. This is perfect square, so the result is 5. So we are okay now. And 4 to the power of 1 over 4, this is like 2 to the second power, and the whole thing to the power of 1 over 4. I do the multiplication again. 2 times 1 over 4 is 1/2, so this is gonna be like 2 to the power of 1/2. Okay, good. So now let's have a look what can we do here. We have the same basis here, so we can still simplify. I'll do it like slowly, so I don't do anything with the numerator, and in the denominator I will have 2 to the power of 3 over 2 times 5 to the second power. As you can see, we have the same basis here, and again there is a formula which says a to the power of r over a to the power of s is equal to a to the power of r take away s. So we just simply do subtraction. 2 over 9 take away 3 over 9, which will lead to 6 over 2, which is basically number 3. So we will get 2 to the third power over 5 to the second power, which is very nice number, 8 over 25. So this is our result. Nothing special. Just doing the multiplication of the powers, and sometimes doing the addition of the powers. Okay, so let's have a look to the next exercise, which is this one. The question is what can we do here, but this one is really like very easy, because here you really do nothing, just multiplication and addition or subtraction of the indices, okay, of the powers. So I can simplify my first expression, which is this one. Okay, it's gonna be x to the negative 4 times z to the negative 6 over a to the negative 2 times b to 8. And as we already know, division means multiplication, so we just switch the numerator with the denominator, so it's gonna be a to the negative 2 times b to the negative 3 over x to the negative 2 times y to the third power. Okay, nothing special. We can simplify and write it like really as one fraction, so it's gonna be x to negative 4 times z to negative z times a to the power of negative 2 times b to the power of negative 3, a to the power of negative 2 times b to the power of 8 times x to the negative to the power of negative 2 times y to the third power. Okay, what can we simplify here? You just find the same basis, which is this one with the a's. Good news, they have the same power, so we will get rid of them, so there won't be any a in our solution. Do we have any z power? No, we don't have any z power, which means z to the power of negative 6 will remain. B, okay, this is gonna be like times b, negative 3 minus 8 is negative 11, so I'm done with this, just to be sure that I did all the things properly. X, so it means negative 4, take away negative 2, which means negative 4 plus 2, so this is like x to the negative 2, and the last thing is y to the negative 3. And as I don't like negative numbers in the powers, I can simplify these like 1 over b to the negative b to the power of 11 times x to the second power times y to the third power times z to the sixth power, and I'm done. Nothing else can be done here. My expression was simplified, and I'm done with this one. Okay, the last task is to simplify this super special tricky thing, but this is really like very easy. I showed you during the lesson. You can do it with the powers or indices, exponents if you want to, or you just simply use the radicals. I will use the radicals, so it means it's the fourth root of x, third root of, and now the first thing I want to put this one inside of this, so it will be second, so it will be square root of, and as x goes under the square root, it's gonna be x squared times x, which means it's gonna be x to the third power. Okay, now I can simplify these two radicals, so it will stay like the fourth root of x times, and we already know that we have to multiply, so this is gonna be sixth root of x to the power of 3. Okay, this is gonna be then fourth root of, now I'm gonna put this one inside of under the root, so it means it's gonna be sixth root of x to the power of 6 times x to the power of 3 is x to the power of 9. Now I'm gonna multiply these two, so this is gonna be like 24th root of x to the power of 9, but as you can see, I can simplify because this can be represented like x to the power of 9 over 24, and as you can see, this is not like the proper fraction, so we can simplify by dividing numerator and denominator by number 3, so it will be 3 over 8. This is okay if you provide the result like this, but I would prefer to write the result as we were talking about the radicals this way. But the same thing with what we did here, you can do here. Okay, so my friends, this is it. I'm looking forward to see you during my next video about I don't know which topic. Study and have a nice evening.